Hi everyone, my name is Afshin Amini and today I want to present GDive. GDive is a multi-agent application designed to solve a major bottleneck in geotechnical, forensic, and consulting firms, which is the time-consuming process of reviewing and extracting information from technical reports. In geotechnical and mining projects, legal disputes often arise when something goes wrong, such as the failure of a tailings dam. To determine liability, it's crucial to pinpoint the source of the failure. Was it a design flaw, bad execution, or did the issue originate earlier in the project lifecycle? Uncovering the answer to these questions requires careful review of historical records and reports. To get to the bottom of these questions, companies hire forensic geotechnical consultants. These experts conduct field investigations and critically desktop studies to piece together what happened and when. But this is where the bottleneck lies and where GDive steps in. The goal of a desktop study is to reconstruct the project history. To do that, the consultants must gather all available reports, go through each report manually, summarize information in a chronological order, connect information and events across multiple reports, and if at any time or point they require additional information, they have to repeat this whole process, which, as you can imagine, is both time-consuming, prone to human error, and costly. GDive is built to transform this process, making it faster, more accurate, and more cost-effective. Instead of spending weeks manually reviewing documents, users simply upload the reports, ask their questions, and receive a clear, consistent answer organized in a chronological order. Behind the scenes, GDive uses two agents to make this possible. An information extraction agent that reads and structures the contents of all uploaded reports, and an information retrieval and question answering agent, which answers the user's questions based on the extracted facts. In this application, the user begins by uploading multiple reports into GDive. The system then processes all documents and generates a downloadable file containing structured facts extracted from text. Each fact includes a report metadata, for example, report name, page number, a topic, a statement, tags, and a date associated with that statement. This transforms the unstructured reports into a clean, searchable database of project history. Once the facts are extracted, user can upload them into GDive's question answering system. From there, they simply ask their question and receive a clear, well-structured answer built from the most relevant facts presented in a chronological order. Behind the scenes, GDive uses a retrieval augmented generation engine to retrieve the most relevant facts related to that question and generates a comprehensive answer using those facts. This two-step system design is intentional. It means users don't have to reprocess reports every time they need new information. They can reuse the extracted facts as often as needed, saving both time and computation costs. To assess performance, we started with 200 AI-generated question-answer pairs based on 4 real-world reports. After filtering out irrelevant pairs, we tested the system on 171 valid questions using a large language model as a judge. With prompt optimization, the QA system achieved an accuracy of 92 to 93% at this stage. And Further on, to ensure the LLM judge was reliable, we manually reviewed a sample of 20 questions, which with 90% of his judgment matched human judgment. And in two cases, there was agreement. In one case, the generated answer referred to a correct section in the report, but it didn't provide the numbers that we're looking for. And second case, the presence of a contradictive information in the report caused a wrong answer. So basically, there were in two sections of one report, there were contradictive information related to one event. These edge cases highlight a key challenge in this application, which is ensuring the system provides a complete answer based on user's question. In summary, the main goals that I was looking for was to create a QA system that has high accuracy and consistency, and also a system that can gain users' trust through transparency and traceability of the generated answers. Throughout this project, we developed a core architecture of a multi-agent QA system tailored to geological documents. And the next steps compose of adding a fact checker and completeness validator agents to make sure the generated answers are complete and there's no hallucination. Further evaluation by adding more reports and different types of reports, and also enhancing user experience to provide a smoother interaction and better adoption. Thanks for your time. I'm looking forward to your comments and suggestions.